We're out in the shop today doing a welding repair. I've got a shaft from a mower that we'll take a look at here that actually broke and cracked out. So we're going to do a little bit of dimensional restoration with TIG welding, see if we can't build that back up and get this thing back on the tractor and mowing lawns. Now this shaft is quite dirty. It's been in farm use for a number of years and has seen its better days. So what we're going to do is try to get down in here into this groove and clean out as much of that rust as we can so it doesn't interfere with our TIG welding. I'm going to use a Dremel tool. Got a nice small little wire wheel that I think is going to fit down in there and do what we need it to do. After just a couple of minutes of grinding, we've got this thing pretty cleaned up. All the rust has been removed, and I think we're ready to take it to the next level. Now, we're bound to run in a little bit of grease, oil, and other contamination, because like I say, this thing's been in service for years. It is not a new product. So we're going to be real prepared when we hit this thing with a TIG arc. And if we see any contamination or any off-gassing, anything burning, we're going to stop right away. We're going to apply a little bit of heat to burn that off. We're going to re-clean it up and we'll go back at it. But this is a quick repair, basically just for a local farm implement. It doesn't need to necessarily be 100% perfect. As you can see, the shaft is in kind of rough shape. But I think that if we do this, it's going to work, it's going to serve its purpose, and it's going to meet the intended application, which is the big deal here. Let's get set up for welding. Let's get set up to weld that shaft. We know it's some kind of a steel, probably a chrome alloy. So we're going to use DC electrode negative, which we're already set in on the front panel of the machine. I'm going to be using high frequency start, which is our top selection here, the HF impulse mode. We're going to use a standard foot pedal so that we can control the output while we're welding. And I can easily sit at the bench, so a foot pedal is going to work good for us. I'm not going to do any pulsing. I'm not going to use the sequencer. I have to make sure that my post flow is enough to accommodate the amperage that I'm going to use. So what I'm going to say for amperage, I guess right now, is we're going to be probably cranking this thing up to 200, because in order to get that thing to wet out and not put a lot of heat into it, right? We'll sit there and heating it without melting it's not a good thing. So we want to get on the shaft, we want to form a puddle, we want to get it welded and get off. We're also going to try to control how wide the bead is, because the wider the bead, the more distortion. So we're going to be feathering it back and forth. At that rate, if you have an automatic post flow setting, the machine's going to take over for you no matter what your foot pedal gets to. I'm going to set mine at about 10 seconds, which is less than we normally would use at 200 amps, which would require about 20 seconds. Experience tells me I'm probably not going to be that high. I'm going to be letting the tungsten cool down as I ramp down, and 10 seconds should be good. If I notice any discoloration in my tungsten, I can come on back over here and increase the post flow time. Now to set up the TIG torch. I'm using an air-cooled number 17 because this is a relatively short weld. We're going to be at some amperages, maybe 150 to 200, but it's going to be very, very short time. So we probably don't need to use a water-cooled torch in this case. I'm going to use a 332 2% ceriated tungsten. It happens to be one of my preferable tungstens. And I can normally just use a standard ceramic cup, but in order to improve visibility for everybody that's watching, I'm going to go ahead and switch over to one of these clear Pyrex cups. And in order to do that, basically I just screw this adapter right onto the TIG torch. So we'll get this all set up and ready to go. Now let's take a look at how to properly set up your TIG torch. You can see here I've got the back cap threaded in, but it's loose so that we can get everything else threaded into the torch. I'm going to drop my collet down inside my collet body, and I'm going to thread that into the torch head all the way. All right, so back cap's loose, this is threaded in all the way. At this point, I'm going to go ahead and slide my tungsten in. I'm going to thread on my adapter, and we're going to slide on our Pyrex cup. Once I tighten down the back cap, the tungsten does not move, and this O-ring right here prevents any gas from seeping out the back if there's a gap between the cup and the insulator. So we should be all set up to weld. Just as a note, you don't need to use any tools or wrenches on your TIG torch. In fact, we recommend that you don't use any tools and only finger tighten these connections. If you over tighten them, you could strip the threads inside the TIG torch and cost yourself a significant amount of money. Another thing that I recommend when you're doing repairs, or really best practice for any welding, is to attach the work clamp directly to the part so that we know we've got a good work path and a good work connection to complete the secondary loop. And we don't have to worry about that path going through a painted or corroded surface, maybe arcing through a bearing that's on this thing. All right, I got a piece of 1/16 ER70 S2 filler wire, which is a steel filler wire. We're gonna go ahead and strike an arc here. We're gonna see what it looks like and see if we're clean enough to continue on. Good news. We were able to put a weld down with no porosity, and I think we're ready to move forward. Give this a quick wire brush. We're going to go ahead and put another bead right on top of that one, and then we're going to skip to the other side after we let it cool down a bit. Now it's off to the machine shop to reshape that key slot. Well, that was a quick little TIG repair that just required some cleanup and a little bit of metal restoration on the edge of that key slot. Now that we've got that done, after a little sanding, a little grinding, and some machining, I think this thing can go back on the tractor, back in the field, and back in service.